Look closely enough at the fabric of reality, and it's easy to feel like you're trapped inside a video game. The idea that we are code running on some unimaginably powerful supercomputer has infected pop culture completely, and physics gives us plenty of reasons to be suspicious. When you look at this diagram zooming in to the quantum scale, you see that the universe has what looks exactly like a render limit. There is a hard cap on how fast anything can move, the speed of light, and an unbreakable baseline pixelation at the Planck length where space itself stops being smooth. But we are making a massive conceptual leap here. We are looking at the physical limits of information and jumping straight to the conclusion that an alien programmer built a machine to simulate us. To untangle this, we need to map out exactly what we mean by a simulation. This chart breaks the idea into 4 distinct categories. The first is the mathematical model. This is the idea that the universe can be described by math. That is trivially true, and nobody argues with it. Then, as the highlight drops down a row, we hit the information processor. This suggests the universe processes data, where an input becomes an output. Again, this is standard physics. Every time particles collide, they are essentially computing their next state. The third category is the sci-fi trap, the external simulator. This claims there is a server rack in some higher dimension running a universe executable file. We can cross this one out entirely. Instead, we focus on the fourth category, the internally self-consistent finite record system. This model adopts the same state-dependent update and resource constraints used in modern thermodynamic physics. By shifting to this fourth definition, we leave the matrix behind and enter a theoretical framework called Finite Distinction Systems, or FDS. FDS starts by throwing out the assumption that reality is an infinitely detailed, perfectly continuous backdrop. It asks a much stricter question: what can actually be physically recorded? To answer that, we have to look at what FDS calls a finite observer. This isn't necessarily a conscious human mind. It can be a laboratory sensor, a biological cell, or any physical system measuring its environment. Every physical system operates under a strict thermodynamic capacity budget. It only has so much memory. Watch the data hitting this bottleneck. At its capacity limit, an observer cannot process infinite detail. It compresses reality into manageable blocks. But that lost micro-detail doesn't vanish. The sheared-off data points radiate away as thermodynamic heat. Deleting physical records costs energy. So what pop culture insists is just a rendering glitch or a resolution limit programmed by a creator is actually the hard thermodynamic boundary of our own equipment. We are finite systems trying to read an overwhelming universe. That raises an obvious counterargument. If there is no grand programmer typing out the source code, why does the universe run on such elegant, highly structured mathematical equations? Think about the raw, microscopic history of every single particle interacting in a room. It is a completely unmanageable volume of information. No finite system could possibly track or store it all over time. To solve this massive data problem, the FDS framework points to a concept known as invariant form compression. Watch these chaotic particle trajectories filtering through a lens. The universe compresses erratic histories into a clean mathematical rule, preserving only stable relationships. A physical system doesn't store every case. It only records the relation valid across all of them. These laws are the portable residues of physics, the only structure stable enough to survive the constant erasure required to maintain a finite record. This brings us to the cosmic scale. If there is no external hard drive or monitor rendering the simulation, what is the physical hardware that actually holds spacetime together? The FDS gravity framework, known as G1, answers this by defining the boundaries of spacetime as causal screens. Watch this surface grid enclosing a spherical volume. These causal screens act as thermodynamic ledgers, tallying physical information crossing their boundaries. As information pushes and flexes the boundary, we see the ledger's entropy response. Gravitational curvature is simply the tension of finite capacity stretching. The universe does not require an external server rack to maintain its shape, because spacetime itself is the boundary ledger continuously auditing reality. Let's step back and look at the whole picture. The universe is computable. it is highly compressible, and it absolutely acts like a massive thermodynamic accounting ledger. But the sci-fi metaphors got the hardware wrong. The screen is a causal horizon. The memory limit is a physical thermodynamic boundary. None of this is running on silicon chips. Humanity looked out at a universe's incredibly precise, self-maintaining accounting system, and our first instinct was to assume there must be a giant accountant sitting somewhere outside of it pulling the levers. Computation is a physical possibility enabled by the universe's internal accounting. We are not watching a simulation. We are watching the ledger update.